When you are working with embedded systems, tracking down a communication error between two microcontrollers can be incredibly frustrating. A simple multimeter or a basic two-channel oscilloscope often lacks the context needed to see exactly where a protocol handshake is failing or why your FPGA is reporting a sync error. This is the Kingst LA5016, a dedicated logic analyzer designed to bridge that gap. It is built specifically for users who need to monitor multiple digital lines simultaneously, offering 16 distinct channels to capture complex timing relationships that would otherwise remain hidden during your development process. At its core, the LA5016 boasts a maximum sample rate of 500 megasamples per second. This speed is generally sufficient for most microcontrollers, ARM-based designs, and typical FPGA interface signals. It provides a reliable stream of data to your computer, allowing you to visualize transitions with high temporal resolution. One of the standout features here is the 10 billion sample memory capacity. Having such a deep buffer means you can leave the analyzer running for extended periods, capturing long boot sequences or infrequent state changes that only happen once every few thousand cycles of your system clock. The unit connects via USB, which acts as both the data link and power source. The accompanying software is designed for Windows and provides a clean interface for configuring triggers and decoding standard protocols like I2C, SPI, and UART, turning raw pulses into human-readable text and hex data. You will find this tool most useful when you are writing your own drivers or debugging legacy code where documentation is scarce. It is ideal for verifying that your SPI clock polarity is correct or checking if your UART baud rate matches the receiver's expectation exactly. Compared to using an oscilloscope for digital logic, the logic analyzer is far more efficient. You can label your channels, group them into buses, and use advanced search functions to jump directly to specific data patterns, significantly cutting down the time you spend staring at raw square waves. Before you invest, consider your signal voltage levels and bandwidth requirements. While this device is excellent for digital signals, it is not a replacement for an oscilloscope if you need to view analog noise, rise times, or voltage fluctuations. Always ensure your probe connections are secure to avoid signal crosstalk. When checking the technical specs, ensure that the 500 megasample rate meets the requirements of your fastest bus. For most standard projects involving Arduino, Raspberry Pi, or STM32, this performance level is more than adequate for professional-grade debugging and diagnostic tasks. In conclusion, the Kingst LA5016 is a balanced, capable instrument for those who have outgrown basic tools. It offers the channel count and memory depth needed to solve complex timing issues without the extreme cost associated with high-end lab gear. It is a solid addition to any digital electronics workbench.